Good morning, Year 5. This is your short fraction video before you attempt today's questions. So we've been looking at equivalent fractions, so fractions that are equal. We're talking about equivalent meaning equal to. So thinking about fractions that are still worth the same amount. So if we're thinking about a half, that would be the same as 10 over 20 or 50 over 100 or 4 over 8. So there's different ways of expressing a half, and what you're doing is breaking up that amount or that shape into different amounts of equal parts, but we're still looking at a half being a half. So whether it's 100 over 200, it still means the same. So we've done it so far with what we would call unit fractions, and a unit fraction is where you've got one part and it might be 1/7 or 1/4, 1/5, whatever. That's a unit fraction. So they're fractions that we're most sort of used to seeing and dealing with. Now we're going to make sure that we've got that understanding that equivalent fractions, we can work with any fractions. We could work with 3/5 like we're going to do today. It could be 7 over 109. So long as we remember that golden rule that whatever you do to one part of your fraction you do to the other, we're sure to have an equivalent fraction. So you're looking to see what the connection is here, because we're trying to fill in the gap. What is the connection between 3 and 6? What have I done to 3 to make it 6? And hopefully you realise that I've doubled it. So what I've got to do is do the same to the bottom number, okay? So I've just got to double that there. So 3/5 or 3 over 5 is the same as 6/10, okay? So like I said, all you've got to do is to make sure you're doing the same to both parts of your fraction, and then you will have an equivalent fraction. So we're not going to be creating equivalent fractions. You're not going to be giving me a long list of equivalent fractions for 3/5. What you're going to be doing is what we've done this week, which is looking at the connection between the original fraction and then the part of the fraction that you've been given. So I'm looking the connection between 5 and 45, and I'm thinking, what have I multiplied? I've definitely multiplied it because I've made it bigger. What have I multiplied 5 by? And I've multiplied it by 9. So all I need to do is to make sure that I'm multiplying my numerator, my top number, by 9 as well. So 3 times 9. So 3 times 10 is 30. So 3 times 9 is 3 less than 30, so it's 27. Okay. And again, each time we go back to that original fraction. So I'm looking at, I've got 36 as my numerator. So what am I multiplying 3 by to get 36? Well, 3 times 10 is 30, 3 times 11 is 33. So I'm multiplying it by 12. And the more familiar you are with your times tables, the easier you will find this. So your challenge yesterday, the maths challenge I set you, was about having a way of working out a times table that you didn't know. So you're going to need to use that strategy today to help you look at the connection between numbers that maybe are in times tables you don't know. So I had to times 3 by 12 to get 36. I must times 5 by 12, which is 60. So we are moving our understanding of fractions on, but actually it's just one simple step, because what we're looking at is fractions that are a bit more unfamiliar to work with. And it's just to reinforce that idea that it doesn't matter what number is at the top and the bottom of your fraction. So long as you're doing the same thing to both numbers and multiplying them or dividing them by the same number, you will get an equivalent fraction. Okay, well, good luck, and then come back and watch the answer video for the rest of the questions.